So in electrostatic, sorry lah tulisan buruk kan. Saya tak biasa pakai benda lah ni.
Tak apa, tak apa.
Okay, so in electrostatic, basically we are deal more to electric field lah. Okay, so kita akan deal lebih untuk electric field. Okay, so under this electric field, so we have two important parameter. So which is electric field intensity. So this one is a field lah, field value kan. And then the other one, so we have D. So this one is a flux value. So basically when we go to magnetostatic, so we will have almost similar argument lah in terms of field and as well as the flux. Okay, so let's say we have charge here, so positive charge for example, and basically this charge will be produce field. So this one is what you have been learned before. Okay, kita ada field. Okay, so if we have a positive charge, then direction of the field will be going outward from our charge. Okay, so basically what we have here, so basically we have the vector of E that represent our field intensity. In order to evaluate how strong that the field has been produced by that particular charge. Okay, and basically the charge is the field is represented by this line. Okay, so the field is determined by this line, and this line, so we call it as a flux. Okay. In order to evaluate the performance of flux, so basically we are evaluating in terms of D value, so the vector of D. Okay, so and we have expression ataupun relationship between D and E. So we have D is equal to epsilon E. Okay, whereby this value of epsilon is depending on the material lah. Okay, and basically so we will have epsilon is equal to epsilon R epsilon naught. Okay, macam pagi tadi ada yang confuse juga epsilon naught ni apa kan. So epsilon naught ni ataupun nilai dia berapa kan. Epsilon naught ni basically kau boleh dapat daripada kalkulator lah. Kau tekan constant, tekan nombor 32, so dia akan keluar lah. So basically the value for this constant is about 8.854 times 10 power of minus 12 I think farad per meter lah. So nak dapat yang apa yang tepatnya boleh check dalam kalkulator masing-masing lah. Okay. And this value of ER or relative permittivity is depending on the material. Okay. So as you can see in some of the tutorial question, some of the question they mention that so this charge is reside on air gap for example or air in airspace. So in that particular case, so we need to use the value for the epsilon is equal to epsilon naught. Okay. So kadang-kadang especially bila awak study pasal boundary condition, so in that particular case, so the question will give you what is the value for ER, relative permittivity. Okay. So basically in order to derive the expression for D and E, okay, because in the end we need to use both parameter to evaluate our circuit performance. Okay, it's not only our field performance lah. Okay, because in the end of the day, so we need to perform our circuit analysis, sebagaimana awak belajar masa awal-awal dululah. Okay, so basically from the expression that we get to represent our vector D and E. Okay, so basically we can have we can calculate the potential difference. Okay, so whereby the potential difference V is equal to minus summation line integration E dot dl kan, for example lah. Okay, and then from D and E as well we can calculate the value of resistor, so the value for the capacitor tinggal. Okay, apa lagi? Power and etc. lah. Okay. So basically in electrostatic, this is all about electrostatic. Okay. Dan bila kita, when we have electric field, of course we need to consider the material as well. Kan? So, samakan dulu. Okay, in electric perspective, in term of material, so we have two types. So first is conductor, and second is dielectric. So, and apa nama? And because of we have two different conductor, so we have another topic that we need to consider as well. We call it as a boundary condition. Okay. So ini adalah lebih kurang summarize lah what we should know in electrostatic topic. Okay. Boleh tak?
Boleh kata.
Eh. So basically, the most important thing is to know how to derive the expression for E and D. So that one is the first lah. So that's why we learn about Gauss law. We learn about Coulomb's law first, and then we learn about apa nama tu? Gauss law kan. Okay. So to derive the vector of E and the vector for E, expression for those vector. So we have first is Coulomb's law. And second is a Gauss law. Okay. So in this particular in this particular case, then you need to understand lah. So what this law mentioned about? Okay, what is the law? What this law is mentioned about? The characteristic for vector of D and E. Then from that you can know how to derive lah. Okay, so let's say for example for Coulomb's law, so we have a general expression for E is equal to R cap Q divided by R cap Q divided by 4 pi epsilon R squared. Kan? So governed by this Gauss law, so basically, so we have series of equation lah. So closed integration surface for D dot ds is equal to volume integration for del dot d dot dv is equal to surface integration rho s dot ds is equal to q enclosed kan. And when we study about q, okay, even though in this particular case in the Gauss law, in order to find q, so we need to use this expression, but actually in order to find the value of q, instead of by using surface charge density, so we can also find it by using line charge density, okay, yang diwakili oleh rho L. So whereas, so we have q is equal to line integration rho L dot dl. And so the charge also can be represented by using surface surface density. So whereas in order to find the value of q, so we need to perform surface integration rho s dot ds. Okay, so if we have the charge in volume density, so we can find the value of q by performing a volume integration of rho v dot dv. Okay, so it depends on what is the value of charge is given. So either the charge is given in the absolute value or in line density, surface density, or volume density. So we can find the value of Q by using this series of formula. Okay? So by using this series of formula. Okay. So, and then after that is just application of it lah untuk cari apa potential difference kan. So that one yang apa kita duk cari dalam circuit analysis pun kan. So the value of the current. Cumanya in a field perspective instead of current, so we are more interest on the current density. So itu je lah. Kan? So kalau diberi JS for example, so current density. So in order to find the absolute value for the current, so we need to perform the surface surface integration of surface je lah. Integration of surface JS.ds. So itu je secara umum electrostatic. So awak pusing-pusing itu je lah. Okay. So macam mana? If you have any specific question, is more apa nama? It's more apa useful lah kan. So kita boleh apa fokus sikit.
Doktor,
Ha.
yang row L, row S dengan row V tu untuk cari apa?
Yang ini yang mana saya punya kit? So yang ini adalah okay, nantilah saya explain sikit Alright. So basically okay, so basically when we talk about electric field, so the source of this electric field is come out from charge. Okay. And basically the charge can be represented by several ways lah. Kita boleh wakilkan charge ni dalam bentuk beberapa. Okay. Sekejap Alamak, sekejap Kevin Jeffrey, boleh ni dulu tak? Saya tersilap tekan lah. Saya tak boleh tulis. Boleh. Alamak, left dulu terus. Kenapa saya tak boleh ni? Okay. So the charge can be represented by several ways lah. So first, so the charge can be represented by its absolute value. And we call it as a Q. So this Q will be given into how many coulomb? Okay. So yang ini dalam absolute value lah. So kita kata absolute value. So the charge also can be represented by using density value. So instead of we have a single particle charge, so we can distribute the charge in along, for example, so we have one single line of charge. So we have one tiny line, and then the charge is distributed well inside this line. Okay. So in this particular case, so we represent the value of charge in terms of rho L. So the unit is a coulomb per meter. So because of the charge is distributed well in this line, okay, so we can find the value of charge, the total charge distribute inside this line is equal to integration of line rho L dot dl. Then we need to determine lah. So the dl ni, so either we want to find, either we need to use the dl in term of dx, for example. So dx or dy or dz or dr, dr, and etc. So depending on the shape of the line that we are using. Okay. So the second style, if so, let's say we have one surface, one rectangular surface, for example, and then we distributed the charge well in this surface. Okay, so maknanya dari segi distribution dia sama. So in this case, so we will represent the charge in a surface density. So the unit is coulomb per meter square. And in order to find the total charge, the Q is equal to surface integration rho s dot ds. So again, so ds will be determined by using which type of coordinate system that you are using. All right. And the third one, okay, so let's say we are represent our charge, or let's say we distribute well our charge in a certain volume. So let's say in this case in a cylindrical shape. So in this particular case, so the charge will be represented by using volume density, and the unit is a coulomb per meter cubic. Okay. So in order to find how much charge exists in this particular volume, or in this particular shape, so we need to perform a volume integration of rho v dv. So same as well. So the expression for this dv is depending on the coordinate system. Okay, boleh.
Okay.
Alright. So is there any other question? Surya 3. Alright, so let's see one of your friend asked to, ada lagi tak? Okay. One of your friend asked about tutorial 3, question number 6. Okay. So a square with you all semua ada tutorial 3 Ada tak? Yeah, a square with side of 2 meter has a charge 40 microcoulomb at each of its corner. Determine the electric field at a point 5 meter above the center of the square. Alright. So let's say we have, so this is our coordinate system. So x, y, and z. Okay, and then we have a charge. So we have 4 charge. So yang ni, let's say this is our Q1, Q2, Q3, and Q4. Okay. So the value of charge is, the Q is the same, 40 microcoulomb. Okay. So the length of this apa nama ni, square is 2 meter each, and we need to find what is the value for the E at 005. Okay. So 5 meter above or the center of the rectangular. Okay. In order to find this, so we know that the general expression in order to find E is equal to 1 divided by 4 pi epsilon. So in this case, so we just assume that all these charge is reside on the air gap or in the airspace. So we have epsilon naught rather than epsilon. Okay, so summation of I from 1 until, so we have 4 here, 4 Qi. So R minus Ri, so divided by R minus Ri, with the power of 3. Okay, so this is our general expression to find expression for E. Okay, so first we need to find what is the vector or what is the expression that represent by this vector. Okay, so in order to find the expression for this vector, so let's look on our sketch. Okay, so let's say we consider for the first charge first. Okay, so this is our vector R. So this is vector R1. Okay, so in order to find vector R1, so vector R1 is a vector that travel from, so this the coordinate for the Q1 is given by yang ini 1 minus 1, so Z is 0, and the charge travel from this coordinate to 0, 0, 5. Okay, so based on this argument, so the expression that represent our R1 can be derived as follow. So for the x cap component, so 0 minus 1, so plus y cap, so 0 minus minus 1, so 0 minus minus 1 plus z cap, so 5 minus 0, so I take 5 lah. Then we will have minus x cap plus y cap plus z cap 5. Okay, and the amplitude for this vector is equal to 1 squared plus 1 squared plus 5 squared. So we will have square root of 27. Okay, so basically we need to derive the R vector expression for each charge. Okay, for example, this vector, so the vector R that represent the direction and distance from Q2 until E, until this point, so the Q3 and the Q4. Okay, so okay, so if you solve it correctly, so I just share whatever I dah buat sebelum ni kan. So for Q1, so vector of R is equal to, okay, so maybe it's a bit different lah because the notation of what I'm doing while solving this earlier and now could be different lah. So Q1, the R1 is equal to minus X cap minus Y cap plus Z cap 5. Okay, so the amplitude is equal to square root 27. So for the Q2, so the vector of R2 is equal to X cap minus Y cap plus Z cap 5. So the amplitude is equal to square root 27. For Q3, R3 is equal to S cap plus Y cap plus Z cap 5. So the magnitude is the same, 27. And for the Q4 R4 is equal to minus X cap plus Y cap plus Z cap 5. And the magnitude is equal to square root of 27. Okay, then once you get all the vector equation or the expression for the vector, so we can put all together in this apa nama tu equation lah. Okay, so because we have the value for each charge is the same, it's 40 microcoulomb. Okay, so divided by 4 pi epsilon naught. Okay, so for the summation is equal to this one lah, minus x cap minus y cap plus z cap 5 divided by square root of 27 plus x cap minus y cap plus z cap 5 divided by square root 27 plus x cap plus y cap plus z cap 5 divided by square root of 27, and the last one is minus x cap plus y cap plus z cap 5 divided by square root of 27. Okay, then after that it's just matter of to solving this equation lah. Okay. Terusnya tu just solving this equation. So by we're using mathematical, then you get lah. So whatever answer. So based on what I've been done before, so the value of E is equal to Z cap 51.2 kilovolt per meter. Okay guys, so please don't forget the unit lah. Okay, so I think inside that tutorial ada jawapan. So ada jawapan lah, you can check the answer lah. Okay. So basically, as you have seen in this question, so basically you can eliminate the x cap and y cap component. Okay, if you can see here, for example, here we have minus x plus x is 0, and then plus x is x again, and then but then will be minus the x again, then the component for x will become 0. So similar to the y. Okay, and because of we have this kind of setting lah. So because we have each charge is located on the symmetrical position. So of course some of the coordinate will be, ataupun some of the component will be eliminated. Okay. So is there any question? Is there anything that you are not clear?
Kita nak snap yang sebelum ni punya sudah tertulis.
It's okay. I will upload this slide in the Ulen later on. In fact, basically this session is being recorded, and then later on you can you can watch it again lah. So please don't bother to snapshot. It's okay. I will give anything ah. So just take your time to understand the concept first. Okay. Alright, so what else should we discuss? Soalan 10. Okay. Tutorial 3, question number 10. Question number 10. Okay. Okay, tutorial 3, question number 10. Okay. So given the electric flux D, so D is equal to x cap xy power of 3 z power of 3 coulomb per meter cubic for a cube 2 meter on the side. Located in the first octet with 3 of its side is coincident with the xy and z axis and one of its corner at the origin. Find the total Q enclosed by using okay. Alright. Jangan fahamkan dulu. Okay. So we have a cube. So this is our x, y, and z axis. Okay. And basically the cube is reside on the first octant of a three of its side. So maknanya macam ni lah. Okay. So it's located here. Okay. So the length of each side is 2 meter. So one of the corner at the origin. Okay. So inilah. Okay. So this is our corner that locate in origin. Okay. Okay. So from the this one we can solve this equation by this problem by using Gauss law lah. Okay. So basically the question here is about Gauss law. Okay. So first the question need us to find the Q. So by using volume integration of rho v dot dv. Okay. So when we have this one, okay. So in order to solve this one, so because of we have our shape in a cubic or in a Cartesian shape of Cartesian similar shape, so we can have triple integration, whereas we have integration for x, y, and z. So this one is our rho v, and the d is the dx, dy, and dz. Okay. So the limit for x is from 0 until 2. So the y as well 0 until 2, and the z as well is equal to 0 until 2. Okay. Then we have z is equal to 0 until 2, y from 0 until 2, x 0 until 2, and the rho v is given by dia tak bagi kita rho v kan. Okay, tak apalah. So this is the expression for the rho v. Okay. Based on the Gauss law, so we have expression that something like this. Del dot d is equal to rho v. Okay. Because in this question they are given us in terms of d. Okay. So we need to find the rho v first. So del dot d is given in the Cartesian. So we have x cap d over dx, so plus y cap d dy plus z cap d dz. So this one is the expression for the del in the Cartesian. So the vector of d is x cap x y power of 3 z power of 3. Okay. And because of in this case, so we are performing the dot operation. Okay. And then in this side, so we have only x cap. So that's why. So the del dot with d is will be left us with del dot dx with x y power of 3 and z power of 3. So by solving this expression, then we will have y power of 3 and z power of 3. So this one is the value of rho v, and the rho v unit is coulomb per meter cubic. So, whenever we solve this expression, then we need to put or we need to put this expression inside this operation. So we will have u is equal to integration of x from 0 until 2, y from 0 until 2, z from 0 until 2. So our rho v here, and dx, dy and dz. And basically we can replace directly our rho v with yz power of 3. Y power of 3 and z power of 3. Okay. If you solve this one, then you will have x from 0 until 2. Okay. So integrate y power of 3, then you will have y power of 4 divided by 4. And the limit from 0 until 2. So same goes to the z. So z power of 4 divided by 4. And the limit is from 0 until 2. Okay. So here we'll have 2. Ni macam mana nak selesai? So please solve it. So how much that you get here? So 2. This one will be 2 the power of 4 divided by 4. So this one also will be 2 power of 4 divided by 4. So how much that you get? The answer for this. How much? 32
Bukan 10 ke?
Tak tahu kalau awak kata 32. Saya tak boleh ni.
Jangan 32, 32. Dah datang.
32. Huda said 32. Okay. Alright. Then the question asks us to find the same value, which is find the value of Q. So by using this expression, E dot ds. Okay. So because of in this case, so we have the closed integration surface. Okay. And by considering that, so we have our cubic here. So we have 6 surface. So we have kalau awak bayangkan dadu kan, so we have dice. So the dice has 6 surface, right? So in this particular case, so we need to find, okay, if I redraw again the shape of the cube. Okay, like here. Okay. So we need to perform this integration on the every side of this cube. Okay, so we have a 6 surface. Okay, so let's say we are considering the front surface first. Okay, on the front surface, okay, for the front surface, so we have uh, so here, so we have 4 points. So this will be 2. So this point will be 2, 2, 0, 0. Okay. So this point will be 2. So the y will be 2 and 0. So this point will be 2, 2, 2. And this point will be x will be 2, y will be 0. For the z is become 2. So that means that so we need to find, or we need to perform this surface integration for each surface. For example, on the front, so we have in this case the value or the coordinate that fixed just as I shown just now is a x axis. So this is x, this is y, and this is z. Okay. So the value the value that fixed for each coordinate is x value. Or in other way, we can say that so the direction of the surface in the x direction. So we need to perform this derivation in xy variable. So we have y from 0 until 2. So z as well from 0 until 2. So we have the expression for d is equal to x cap x y power of 3 z power of 3. Okay, so dot with x cap dy and dz. Okay, so because of we are performing a dot product, so x cap with x cap will become 1. So we will have, and by solving this inside integration, so we will have x, and by solving this one, so we'll have multiplied by y power of 4 divided by 4. So the range of this y is from 0 until 2 dot with z the power of 4 divided by 4, and the range of z from 0 until 2. Okay. So in this particular case, so the value of x is put as 2. Okay, because of this surface is located at the x equal to 2. Okay. So if you put all the values, so this is 2 dot with y power of 4, 2 power of 4 divided by 4 dot with z power of 4, so 2 power of 4 divided by 4. Okay, so I think it is the same as previous one. So this one will be come to 32 coulomb. Okay, then we need to perform the integration on the back side. Okay, on the back side of the uh, qubit. So this side. Okay, for the back, so the or the surface integration d dot ds is equal to, okay, so on the back side, so the direction of the surface in a negative x cap. Okay, and So we have here is our z axis, x axis, and as well as our y axis. Okay. So because of the direction is negative x, so we still have the same limit. So y, okay, so the value of y will be changed from 0 until 2. So 0 until 2. So z is from 0 until 2 as well. So 0, 2. So the expression for the vector of d is equal to x cap x y power of 3 z power of 3 dx dy. Oh, sorry. X cap dy dz. Okay. So by solving this one, then we will have equal to x. Okay. So in this case, if you see that this surface is placed on the x equal to 0. Okay. So we will have this x equal to 0. Okay. So by integrating this one, then we will have y power of 4 divided by 4. So from 0 until 2. And then z power of 4 divided by 4 from 0 until 2. Okay, so because of in this case x equal to 0, then this expression will become 0. Okay, so then we need to perform on the for example on the right side here. Okay, so this is z, x and y. Okay, so we are trying to performing right side, this right side. Okay, on the right side, so basically, so we need to perform because of the direction of the surface in the positive y. So we need to integrate to perform integration from x from 0 until 2. Okay. So x is changed from 0 until 2 and z is changed from 0 until 2 as well. So z is from 0 until 2. So the expression for the d is x cap y x cap x y the power of 3 and z power of 3 dot with. So the direction of the surface is y cap. So y cap dx and dz. Okay. So in this case, definitely if you solve this one, you will get the value. The answer for this expression is equal to 0. Okay. Because in this case, when we perform dot product between y cap and x cap, okay, so the answer for this operation will become 0. Okay. And actually, the same goes uh, for the left surface here, and as well as for the top and bottom surface. Okay. Top and bottom surface. Okay. So because of we have our vector of d, so d is in x cap component. So when we deal, for example, for the top side of surface, the top side, the direction of the surface is in the z cap direction. So definitely when we perform a dot product between x cap and z cap, so the result will become 0. So therefore, for the left side, okay, so the surface integration for d dot ds is equal to 0. Okay, similar to the top as well. Okay, d dot ds is equal to 0. Okay, so the bottom as well. Okay, so the surface integration d dot ds is also equal to 0. And in order to complete our answer, okay, because we have close integration of surface d dot ds. So basically is equal to d dot ds on front plus surface integration of d dot ds on the back side. Okay, so plus surface integration d dot ds on right side plus surface integration d dot ds on the left side. So plus on the top and the bottom as well. Plus bottom. Okay. And because of we have only some result on the front side, which is equal to 32 coulomb. So the rest will become zero. So the answer for this will be equal to 32 coulomb. And if we check with the first answer here, so basically we can conclude that the answer for volume integration rho v dot dv is equal to closed integration surface d dot ds. So whereas in this particular case, so we having solved this equation, we get the result is equal to 32 coulomb. So similar to this operation as well. So we have the answer for this expression is equal to 32 coulomb. Okay. So this tutorial is only to prove that if we have different style of solving, ataupun if we use different equation, as long as it govern under the Gauss law, so we will have the same result. First request is tutorial. Okay, so I get some requests here. Tutorial number 3, number 12 and 2. Okay, 3. So we look to the into the soalan nombor dulu Question number 2 first lah. Betul ni macam senang sikit. Okay. Tutorial 3. Question number 2. Do you mean by baringkan? Kalau kita What do you mean by baringkan? I mean, can you speak your mic and then explain to me? Okay, so we see the solution first Alright. So find the total charge contained in cylindrical volume defined by R. So R less than 2 meter. So Z is from the axis. It's okay. We see based on this question first. 0 until 3 meter. So if given us rho v is equal to 20 Rz millicoulomb per meter cubic. Okay. So as you can see in the tutorial question, okay, so we need to find the Q with the given rho v. So we have Q is equal to volume integration of volume rho v dot dv. Okay, and in this case, so because of we are deal with a cylindrical system, okay, so we will have a triple integration. So we have R from 0 until 2. Okay, as you can see here, the radius for that particular cylinder is 2 meter. And then the phi is from 0 until 2 pi. So by considering a full structure of cylinder, and the z is from 0 until 3. Okay. And then if we put the question, the equation here, 20 Rz, and the dv is equal to R dr d phi and dz. Okay, so the expression for dv is by considering we are dealing with a cylindrical coordinate system. So by referring into the shape of that particular volume. Okay, and if we solve this one, okay, so let's say for the r first, so we have 20 here. So r here is r squared. By integrating it, we have r power of 3 divided by 3. So the limit from 0 until 2. Okay. So we didn't have any phi here. So we can put phi. So 0 until 2 pi. And the solution for the z will be z power of 2 divided by 2. And then the limit of z is from 0 until 3. Okay. So how much did you get if you solve this one? 20 2 power of 3 divided by 3. So multiply by this one will be 2 pi. So this one will be 3 power of 2 divided by 2. So how much did we get here? So you please apa use your calculator, some activity. So how much? Dah selesai belum? This answer you get here. Hmm? How much? Sebab you have to make some exercise, otherwise you will apa fall asleep ah. Mengantuk petang-petang ni. So how much here? Berapa nilai yang sepatutnya kita dapat? Ha? Anyone? Fazrul Nashrik. Ini kan ngantuk kan, tiba-tiba saya cakap seorang je. So please use your calculator.
Betul jap.
Did you left your calculator in your tab?
2.51K, doktor.
1.51.
1.5.
1.5.
1.5 C.
0.5.
1.
Sepakat semua
Betul. Saya setuju.
if all of you get the same answer, then the answer is correct lah. So one of your friends said, manipulated variable on the radius axis. So what does it mean? I don't get it.
Maksudnya dibaringkan kod.
So that means that the height of the cylinder will be on y, for example. So this is the original one. So this is z, this is x, this is y. Okay. So the original one, the center of the cylinder in the z-axis. So in this case, what will happen if we have this kind of situation? Right. Okay. If we have this kind of of orientation, for example, then basically it's about the same. Okay. So, but in this case, so we need to perform as well the triple integration by referring. We are integrate this cylinder in a full structure. So in this case, so R is from 0 until 2 as well. Okay, by considering that, so we might have the same value of resistance. The same value of radius. So the phi is from 0 until 2 pi. Okay, in this case, instead of by referring the z-axis, so this time maybe we need to integrate in the y-axis, y from 0 until 2, for example. So in this particular case, so let's say we are referring to the same expression, 20 rz, for example. And in this case, maybe we will have the r, dr, d phi, and dy instead. Okay, but basically you will get the same answer. So however, most of the case when we deal with the cylindrical, okay, so normally the center of this cylinder will be lies on the z-axis, not on the y-axis. So most of the case lah. Okay, so this one is quite rare case lah. I didn't see it before. Okay, so but don't worry. Basically, the shape of it and the axis, the axis that the shape used basically will be follow to the its nature lah. Okay, apa yang biasa lah, what is normal setting of it. So basically, it will not have this kind of orientation instead. Okay. All right. So can we move to the question number 12? So, but in terms of the coaxial wire, so basically we can make our z-axis in this direction, so no problem. So we just change instead of y-axis here, so we replace with this as a z-axis. Okay. All right. So just now I received request to discuss on the question number 12. So can we move to the question number 12?
Image method, maybe.
Image method
Maybe we can discuss about the image method.
Okay, right. So I give some brief apa nama? Brief ni lah. Brief theory. So what is the image method is all about? Alright. So far, what we have, the condition that we have. So they say we are considering the charge in a particular charge. Okay. They say we have one charge. So let's say a positive charge. And if we have a positive charge, so basically we will have some field that induce around it. Okay. So we will have E here. Okay. So and then we can calculate or we can derive at any position the expression that represent by this field. Okay. We say we have one testing point here, test point P here. Okay. So we can find E at P. So they say by using Coulomb's law is equal to 1 pi Q divided by 4 pi epsilon r squared. And the unit vector of it is r cap, for example. Okay. So in this case, so we have a quite free space. Okay. So free space around this charge. But what we have in the image method, so let's say we have one cube here. Okay. So instead of we have free space, okay, so around this charge. So what we have here, so we have one plane here, and this plane is rounded. Okay, so we have a plane here, and this plane is grounded. So when we have a grounded plane here, so we will have the potential here. So the potential on this plane is equal to 0 volt. So in this case, we cannot use either Coulomb's law or Gauss law. So in order to find, so let's say the potential, the electric field here, for example, okay, because of the existence of this plane, okay, existence of the plane. So normally what we have, so we have one free charge, and the free charge is located on a free space. Okay, so we didn't have any sort of, in this case, we have a zero volt plane. Okay, so because of that, so we need to create one situation so that it represents almost the same on what we have here. So that's why, so in order to find the value for the electric field in this case, in this point, for example, so we need to create another charge here. So the value or the sign of this charge is negative. Okay, so let's say this is a positive, so this side will be negative. If this side is negative, so this side will be positive. And the distance between our charge and the plane must be the same. Okay. So for example, in this case, so we have the distance between this charge and a plane is equal to d. So this one also will be equal to d. Okay, but maybe in a different direction, so in negative direction compared to the original charge. Okay, so if we have this one, so this this situation is almost what we have in a dipole. Okay, so whereas we have one positive and negative charge, and in this case, so the field that exists will be this. Okay, so the field will be travel from the positive to the negative particle charge. So in this case, in a dipole arrangement like this, so basically what we will have, basically in between this charge at the center, so we will have a zero potential. So that's why in exercise of this topic, So I need you to derive or to prove that. So basically, the if we have a dipole arrangement like this one, so you need uh, to derive or to prove that. So the center of between this charge, the potential of it is equal to 0 volt. Okay, so that's why in the exercise you need to perform V is equal to 1 divided by 4 pi epsilon. So this one will be summation of I is equal to 1 until n. So Q, so divided by R squared. Okay, and because of uh, the distance between the charge and the plane, okay, why the original and the image charge to the zero volt plane is the same. So in this case, so the direction from this charge to this plane in this direction also will be the same. So in this case, so we will have 0 because of the value of charge is opposite from each other. So you will have, if we consider this part of equation, then we will have Q divided by R1, so minus Q divided by R2. And because of we have R1 is equal to R2, okay, and as well as the magnitude of Q is the same, okay, so this part of equation will become 0. Then we will have the V is equal to 0 at this grounded plane. Okay, so the charge also in this case can be exist in either rho L, rho V, and as well as rho S. So that one is just we just to solve we just to in order to find the Q. Okay, so basically if we have rho L, so we just integration to perform line integration. So rho L dot dl. Okay, so kalau if the charge is exist in the rho S, so we need to perform surface integration rho S dot ds. If the charge is exist in rho v, for example, so we need to perform a volume integration rho v dot so dv. So that's all for the image method. So the problem in this method is the existence of this plane. So how are we going to solve it? So that's why we introduce the apa nama, image method is being introduced. Then when we have this setup, so basically we can find the for example the E or the D, electric field intensity and electric flux density by using any method. So either using the Coulomb's law or by using the Gauss law. So depending on the how how that particular question represent the Q. If that particular question represent the Q by using density value, for example, so maybe it's easier to using a Gauss law. But if the question give the value for the charge in absolute value, particular charge, so maybe the Coulomb's law is more appropriate. Okay, is it clear for you for the image method? But the thing is, when we set up an image charge, in this case, so basically every time you put the image charge, you need to check so the voltage here, whether the voltage is really 0 or not. Okay. Is there any question regarding the image method? All right. So let's say tutorial 4, question number 11. Okay. Okay. So you can refer to your the question. Alright, so in the following figure, charge Q is located at a distance d above a grounded half plane located in the xy plane and at a distance d from another grounded half plane in xz plane. Use the image method to establish the magnitude, polarities and location of the image of the charge Q with respect to each other in the two ground, as if each is infinity extent. Alright. Okay. So we have this scenario. So we have a grounded plane. Okay. So this grounded plane lies on y axis, and okay, because of this is y axis, so this is will be on exact plane. Okay. So this is on z axis. So the axis will be on xy plane. Okay. And then we have one particle charge here. So this one is a Q, and the Q is located okay, so in a distance of d. Wait, aku tiba-tiba hilang ni. Ahmad, can you stop sharing your screen? Relax. Cool.
Aduh.
Okay.
Okay.
Alright, so we have one Q here. So this is one particle charge, and the particle charge is located on a D, distance of D between both grounded plane. Okay. So and then use the image method to establish the validity of. Alright, so this is positive charge. So this one is positive charge. So basically in image method, so we need to create another charge with different polarity, but the same with the same direction. Okay. So for example, in this case, so we will have another charge here. So the value for the charge will be minus Q here. Okay. Then we will have the balance condition between this Q and this Q by respective to this plane. Okay. Alright, so we will have the same distance here, so D. Okay, and then the polarity of this Q is opposite compared to the original one. Okay. So we solve on this plane. Okay, and then we need to consider this plane. Okay, so we need to also consider this plane. So whereas on this particular plane, so the value for the potential difference is also equal to 0 volt. So that's why in this case we need to create another image here. Okay, so for example in this case, so we have another charge here. The value is a minus Q, and the distance of it is also is equal to D. Okay, which is the same direction as we have here. so that we will have, so this plane also will become a grounded plane. Okay, but in this case, if you find the value of the value for the potential difference on this plane, okay, by considering this arrangement, okay, you might find, okay, so by using the equation that I give, the equation that I share with you in WhatsApp. Okay, so basically if we have this arrangement, so we will have the V is not equal to 0 volt. Okay, because in this particular case, the arrangement of the charge is not balanced. So that's why basically what we have, so we need to create an image as well for this particular plane. So because of we have this shape of plane, so we will have the image for this plane is in this shape. Okay, because in order to make all the value or the arrangement of the charge is balanced to each other. Okay, so if we have another image of the plane in the direction is as shown in this figure. So in order to create this plane is a zero potential, so we need to have another charge here, image charge here. So we will have another charge here. So the value will be opposite to this charge. So we have a positive Q here. And the distance between this charge and this plane is also the same. Is equal to D. Okay. And by creating or by adding another charge here, so basically we also will be balanced with this charge. And because of the direction of here is equal to D, okay, so similar to this direction. So by considering this distance, so we also will balance by adding this value of charge with this charge as well. So both charge will be balanced now. So we have the direction of the charge to each plane is equal to D. So we need to add another three charge. Okay, so let's say in this case, so we have so let's say 0, 0D, okay, in terms of its look, it is a coordinate, for example. Bukan ni macam ni. So 0 DD, for example. Okay, so in this case, so we will have 0 perhaps minus D. So this point will have 0 minus D minus D, and this side we will have a 0 D and minus D. Minus D, minus D, minus D. Okay. Then based on this arrangement, so let's say we want to find E at this point, for example. So E at P, for example. Then we need to derive the vector of or the distance and direction, okay, from each charge to our test point. So in this particular case, so maybe we can use Coulomb's law. So E is equal to 1 divided by 4 pi epsilon summation I from 1 until n. So Qi vector of R minus vector of Ri, so divided by its magnitude, power of 3. Okay, because in this Yeah, so that's all for the solution for this question, because it's not need us to solve anything. So just to establish the pattern of the image method. Okay. So let's say we have another arrangement. So let's say we have like this. So we have one charge, for example, so positive Q. And in this case, so let's say we have the zero plane is something like this, for example, this shape, for example. Okay. And the angle here, for example, 60 degree. So in this particular case, then we need to have so let's say the full circle is 360, right? So divided by 60, so we have 6. So we have another 6. We need to draw another 5 image of this shape. Okay, so for example, so let's say we have this setting. Okay, so this one will be 60 degree. So this one is we will add another charge here. So negative Q. All right. Or so since this is image, so let's draw by using this line. Okay. Okay, so maybe we need to add another one here. Okay, so please check in terms of the angle lah. So this one will be 60 degree. On this side, we will have another charge, negative Q, for example. So the value is negative Q. Then we will need to draw another plane, image plane. So let's say this. Okay. So the angle here is 60. So the image, so we need to add another image charge here. So because of in this particular case, so this image of charge will be image to the discharge. So because of here we have a positive Q. So in this particular case we have positive Q. Positive Q. Then we need to create another plane here.
Test.
Then we will have another Q here. Image. So the value is minus Q. And then so probably we will have another one here. This one supposed to positive Q. Q minus Q. So this one also must be. So maybe the drawing is not to scale, but basically we will have positive Q minus Q, positive Q minus Q, positive Q minus Q, and this way, then the charge will be alternate to each other. If you draw the diagram by using the scale one, then you will have the correct answer. So this one may be the wrong. Maybe this one is 60. So maybe 120 is more here. Maybe. Then we will have okay, so this is the angle. Okay, so each angle is 60 degree. this side will be positive Q and negative Q. So we will have a total of it is six charge. So maybe later on you can draw a scale one. Then you will see that the arrangement. But the thing is, you need to really make sure that this distance is the same. This D and this DC D. So let's say this is let's say A for example. So maybe a different direction compared to the distance between this Q and this plane and this Q and this plane. So this direction will be A and this direction will be D. So for this case, so this direction will be, sorry, this is D. D. So this direction will be D and this direction will be A. So this direction must be A. So this direction will be D. So this one is D. So this one is A. So this one is A and this one is D. Then you will have a balance configuration. So that when you check any point on this grounded plane, okay, on this grounded plane, then you will get the value of it is equal to 0. So it's just to create a balance configuration. So that, and then after that, if we want to find, so let's say the value of E at any point, then we can have any, we can use any method to find it. Amirul Fikri, benung eh. Okay.
Okay. Cun.
So basically the concept is not so hard lah. Basically the concept of it you can grasp it, you can I think you can understand, but um, the thing is how can we analyze it? So how can we, the thing is in electrostatic there are two parameters, there are two important parameters. So first is the electric field intensity and second one is electric flux density. So basically what we are doing is how to derive this expression. So that's why, so we have basically we have two techniques. So we have Coulomb law and we have Gauss law. Okay, so these two techniques can be applied to derive this expression. But this technique is applicable if we have a free space ataupun if we have one charge that located in a free. So we didn't have any obstacle in between it. Okay. If we have any obstacle, for example, in this case, so we have a grounded plane. So in this particular case, we need to adjust the situation so that we can apply any technique to find the expression for E and D. Okay. So that's why in a boundary condition, so let's say we have a two layer of dielectric, for example. So we expose on the for the first dielectric with certain value of electric field. Okay, and then the electric field will travel from one medium to another. So medium 1 to medium 2. And then how can we derive the expression for the electric field intensity and electric flux in the medium 2, provided we know what is the value of electric field in a medium 1, for example. So the important thing is to derive these two parameter. Then you need to apply any technique that you know lah. Jadi
Question 6.
question number 6. Two dielectric media A1 A2 supplied by a battery that has a phase charge density rho s 3.54 times 10 power minus 11. basically we have two medium of 9 liter. This is our boundary. This is our boundary. Okay. So this is our epsilon 1. Epsilon 1 is equal to 2 epsilon naught. And this is our epsilon 2 is equal to 18 epsilon naught. Okay. So that means that this is the media number 1. And this is the media number 2. Okay. And both is dielectric. So the question said that on the surface of this boundary, so we have OF is equal to 3.54 times 10 power of minus 11 coulomb per meter cubic. Okay, so we have this is the vector of E1, electric field in the medium 1, and so let's say this is our E2. So electric field exists in the medium 2. Alright. So in this question, it gives us information on E2. So E2 is equal to S cap 3 minus Y cap 2 plus Z cap 2. So volt per meter. And we need to find the expression that represent our E1. Alright. So in a boundary condition, so we have some information that, okay, so in a tangential component, so we have E1t is equal to E2t. Okay. And in the normal component, so we have E1 E1n minus epsilon 2 omega. Apa persamaannya? Normal component? Betul tak tu? So for normal component, so we will have betul lah. E2n is equal to OV. Okay. Alright, so when we have this kind of field, okay, so we can separate the field by two components. So we have a tangential component here. So this is E2t. This is E1t. Right. So this is our normal component. So this is E2n, and this is our E1n. All right. So based on this vector equation, so we have that E2 is equal to S cap 3 minus Y cap 2 plus Z cap 2. Okay. So on this boundary condition, so we said that, okay, so we said that, so this is our Y axis, sorry, Z axis. So our boundary is lies on XY plane. So basically some information is missing in this question. Okay, but by looking into this question, to find the angle that E2 makes on the z-axis, so we can assume that so our z-axis is in this direction and the boundary is lies on XY plane. So based on this fact, so we have E2T or the tangential component for E2 is equal to X cap 3 minus Y cap 2. Okay. And our E2n or normal component for this vector is equal to Z cap 2. Okay. So based on this fact, we can have our based on by looking into the expression, so we will have our expression for the E12 E1t, sorry, E1t also is equal to X cap 3 minus y cap 2. Okay. So in order to find the z component for this vector, for the E1 vector, so we need to use this expression. Okay. Whereas so we have epsilon 1 E1n minus epsilon 2 E2n is equal to rho v. Okay, so if we put all the parameter that we have, so E epsilon 1 is equal to 2 epsilon naught. Okay, so E1n is the value that we want to find. Epsilon 2 is equal to 18 epsilon naught. Sorry, this one is E. So E2n is equal to 2, kan? Okay, this one, referring to this one. Okay, so it's equal to rho v. Rho v is given in this question is equal to 3.54 times 10 power of minus 11. Right? So if we rearrange this equation, then we will have E1n is equal to 3.54 times 10 power minus 11. Right? So plus 20, 36 epsilon naught. So divided by 2 epsilon naught. Okay. So by solving this one, ada jawapan tak kan? Right. So based on this one, then we will have the value for E1n ataupun normal component for E1 is equal to 20. So therefore, we can write the expression that represent our E1 is equal to x cap 3 minus y cap 2 plus z cap 20. The unit is volt per meter. So don't forget about the unit lah. Okay. Boleh dapat? Boleh?
Oh.
Kat mana yang tak faham? So where did you don't really understand how to solve this one? Do you get what I'm trying to do? Dapat tak? Boleh tak ni?
Boleh.
Boleh Alright, so we go to the second question for this question.
Oh.
Right, so they ask us to find the axis, so the angle between E2 and Z axis. Alright, so in order to find it, so we need to perform the dot product. So E2 dot with Z cap is equal to amplitude for E2 dot with amplitude for Z cap cos theta. Okay, so E2 is equal to x cap 3 minus y cap 2 plus z cap 2. Okay, so dot with z cap is equal to, so the amplitude for E is equal to 9, 4, 13, 13, 17. Okay, square root of 17. Okay, amplitude for the z cap, so this one is a unit vector, so the amplitude is equal to 1 cos theta. Alright, so if you look into this operation, so we need to perform the dot product operation. Okay, and because of in this case on this part, so we have only z cap, so that means that for the other component, when we perform this operation, we will become 0. So that's why, so we have here is 2 is equal to square root of 17 cos theta. And the theta we can get is equal to cos, inverse cos 2 divided by square root of 17. Okay. So if we refer to the answer is equal to 61 degree.